Quantum physics. Quantum physics is a branch of physics that deals with the behavior of matter and energy on the smallest scales, such as atoms and subatomic particles. Some key concepts in quantum physics include wave-particle duality, the idea that particles like electrons and photons can exhibit both wave-like and particle-like behavior. Quantum superposition, the principle that particles can exist in multiple states simultaneously until measured. Quantum entanglement, the phenomenon where particles become correlated in such a way that the state of one particle instantly affects the state of another, even when they are far apart. Quantum tunneling, the process by which particles can pass through energy barriers that would be classically impenetrable. Blockchain technology. Blockchain is a decentralized digital ledger technology that underpins cryptocurrencies like Bitcoin. Here's an overview of how it works. Decentralization. Instead of a central authority, like a bank, verifying and recording transactions, blockchain uses a network of computers, nodes, to collectively validate and store transaction data. Blocks and chains. Transactions are grouped into blocks, and each block is cryptographically linked to the previous one, forming a chain. This creates a tamper-proof record of all transactions. Consensus mechanisms. Various consensus algorithms, e.g., proof of work, proof of stake, ensure agreement among nodes on the validity of transactions without the need for a central authority. Smart contracts. Self-executing contracts stored on the blockchain that automatically enforce the terms of an agreement when predefined conditions are met. Explaining blockchain technology involves discussing its potential applications beyond cryptocurrencies, such as supply chain management, voting systems, digital identity verification, and more. Theory of Relativity. The theory of relativity, proposed by Albert Einstein in the early 20th century, fundamentally changed our understanding of space, time, and gravity. There are two main components. Special relativity. This theory deals with the relationship between space and time for objects moving at constant speeds relative to each other. Key ideas include time dilation, time slowing down for objects in motion, and length contraction, objects appearing shorter when moving at high speeds. General relativity. General relativity extends special relativity to include the effects of gravity. It describes how massive objects warp spacetime, causing phenomena like gravitational time dilation and gravitational lensing. Explaining the theory of relativity involves illustrating thought experiments like the famous twin paradox, discussing its experimental evidence, and exploring its implications for cosmology, such as black holes, gravitational waves, and the expanding universe.